Hello everyone, welcome to the course on operating systems. We are going to discuss about the memory management, and specifically in this session, we will be discussing about the memory hierarchy in a computer, the characteristics of main memory, difference between logical address and physical addresses, and also we will see an address translation process where a logical address is being converted into the physical address. So let us begin with the topics. First of all, we have the memory hierarchy. That means if you look at the computer, we have various memory devices, including the CPU registers, cache memory, RAM, and also the hard disk. This RAM is also called as the main memory or primary memory. And on the other hand, hard disk is also called as the secondary memory. So as we move from left to right, that means from the CPU registers to the cache memory and then to the primary memory and to the hard disk, the speed of the devices decreases. That means it is very easy to access the CPU registers. That means it takes a minimum amount of time to access the data from the CPU registers. And on the other hand, if you look at the cache memory, it is slightly more. The access time is slightly more. And similarly, the RAM access time is relatively more as compared to the cache memory. And at the same time, hard disk, the access time is very high. So the highest access time is for the hard disk and the least access time is for the CPU registers. That means it takes minimum amount of time to access the data from CPU registers and it takes maximum amount of time to access the data from the hard disk. And similarly, if you look at the size, that means the capacity of the devices, it increases from CPU registers, which can store only a few bytes of data, and cache memory or the RAM, it is in the order of a few megabytes, and hard disk nowadays we are getting in terms of few terabytes also. So as we move from left to right, the size increases. And coming to the cost decreases from left to right. That means the CPU registers are very costly. Then cache memory is more costly, and the hard disk is the cheapest one. So as we move from left to right, the cost decreases. So these are the characteristics of different parts of memory that reside within the computer. Now let us see more about the main memory, because the topic is memory management, which is specifically about the main memory management. So let us focus on the characteristics of main memory. So main memory is a crucial component of a computer's architecture, and it is also referred to as the primary memory or random access memory, simply called as RAM. And this main memory holds all the currently running processes and the corresponding data and also the operating system. So if you look at the main memory, it stores the operating system. So OS has to be loaded whenever you switch on the computer. Only then you can execute the remaining applications. So basically, main memory holds the operating system and also all the currently running processes and their data. So operating system also resides in a part of the memory. Generally, operating system either it resides in the higher memory area or in the lower memory area. But most of the computers, they store the operating system in the higher memory area. So the meaning of higher memory means if you start the address from 0 to 1000 and then 2000 up to 10,000. This is the let us consider this as the main memory size, which is 10 KB for simplicity. So in this case, the operating system is residing in the addresses ranging from 5,000 to 10,000. So this is called as the high memory area, and 0 to 1000, and this is called as the low memory area. So generally operating system will be loaded into the higher memory area. And another characteristic is RAM is volatile. That means the main memory is volatile form of memory. The meaning is whenever you switch off the computer, whatever the contents of the main memory will be erased. So only again the operating system will be loaded again whenever you switch on the computer. And if you compare the access time of the main memory with that of the hard disk, it is much less. That means the access time of the main memory is much less as compared to the access time of the hard disk. And one more thing is main memory is also called as random access memory. The meaning is whatever the time that is required for accessing the data from the memory location 5000 is going to be the same as the time that is required to access the data from the memory location 1000. So no matter what the address of the memory is, the time required for accessing the data from any memory location is going to be a constant. That means it is a fixed value. That is why it is called as random access memory. So any memory location can be accessed with the same amount of time. Now let us see what is memory management. So memory management is the process of subdividing the memory among different processes and managing the operations between main memory and disk during the process execution in order to achieve high memory utilization. Just now we have seen that whatever the processes that are currently running or whatever the programs that are currently running will be loaded into the main memory. So the memory management deals with the location, allocation and deallocation of memory to various processes that are running currently. And also whenever a process which is having higher priority has to be executed, then the lower priority processes which are residing in the main memory have to be swapped out to the disk, and we should make a room for the newly arriving higher priority process in the main memory. So in such a case, we need to swap in and swap out the processes between the main memory and disk storage. So these are the functions of the memory management: to allocate and deallocate memory, and also to swap between the main memory and disk storage, to swap the processes between the main memory and disk. And the objective or the goal of memory management is to achieve high memory utilization. So just before we have seen, there are different characteristics of the memory. So as you move from left to right, the cost decreases, but at the same time, the speed decreases, the cost decreases, and also speed decreases, but size increases. So with minimum cost, and we should be able to utilize the memory. That is the objective of the main memory management. Now let us see what is the process of swapping. So whenever a process is to be executed, it must reside in the main memory. So we can't execute any program which is residing in the secondary memory because of the speed mismatch between the CPU and the hard disk. Because if you compare the speeds of the CPU and the secondary memory, CPU is much faster as compared to the secondary memory. So in order to access the instructions from the secondary memory, CPU has to wait for a longer amount of time. So which is wasting the CPU time. So it is wise to bring the process to the main memory, which is having lesser access time as compared to the secondary storage. So that is why whatever the program that has to be executed, it has to be brought to the main memory. And swapping is a process of swapping two processes between the secondary memory and the main memory. So here if you look at the main memory, it consists of the operating system and also few of the processes which are currently running. And let us say initially process P2 is also residing in the main memory, and process P5, which is having higher priority, if it has to be executed, then if there is no space within the main memory, whatever the process that is having the lesser priority, say it is in this example, consider it as process 2. So process 2 has to be moved to the hard disk and process 5 should be brought to the main memory, because process 5 is having relatively higher priority as compared to process 2. So the process of moving the processes between the main memory and the secondary storage is called as swap in and swap out. So bringing the process from the main memory to the hard disk is called as swap out, and bringing the process from secondary storage to the main memory is called as swap in. Now let us see what is the meaning of logical addresses and physical addresses. So logical address, it is the address generated by the CPU, and logical address space is the set of memory locations allotted to a process, and logical addresses are constant. And on the other hand, physical address, which is also called as the real address, is the address seen by the main memory unit. So the set of all physical addresses is called as the physical address space, and the set of all logical addresses is called as the logical address space. And the runtime mapping from the logical address to the physical address is performed by a hardware unit, which is called as the memory management unit. So if you look at the logical addresses, they are constant, which cannot be changed. And if you look at the physical addresses, they can be changed. So let us understand this with the help of a diagram. So if you, let us consider a program which is having a set of instructions. Let us consider instruction 1, instruction 2, and up to instruction 150, which are all the instructions of a particular program. So here the logical addresses are 0 to 149. So 0 indicates the address of the first instruction, 1 indicates the address of the second instruction. So these logical addresses specify the sequence of instructions within a program. So CPU generates the logical address, and whenever this program has to be executed, it has to be loaded into the main memory. And whenever it is loaded into the main memory, it occupies some address space. And whatever the address space that is occupied by the program whenever it is executing in the main memory is called as the physical address space. So basically, CPU generates the logical address, and whenever a program is loaded into the main memory, it has to be referred by using the physical address, because logical address within the main memory is not having any meaning. So provided it is converted into the physical address, only then we can access the instructions from the main memory. So let us understand that with the help of an example. So this is the program where we have a set of instructions ranging from instruction 1 to instruction 151, which are having the logical addresses ranging from 0 to 150. 0 in the address 0 we have instruction 1, in the address 1 we have instruction 2, and so on and so forth. And in the address 150 we have the last instruction of the program, say 151. So whenever it is loaded into the main memory, so it requires around 151 memory words in order to be stored in the main memory. Now let us consider how the logical address is being converted into the physical address, which is called as the address translation. So first of all, CPU generates the logical address, consider it as 150 in this case, and the relocation register value is 2000. So the meaning of this relocation register is, it is the starting address where the starting address in the main memory where the program is being loaded. So that means from the address 2000 in the main memory, the program instructions are being stored. So that is why this logical address 150 has to be converted into the physical address by simply adding the value of the logical address to the relocation address or relocation register. So in that case, the physical address now becomes 2150. And before converting into physical address, there has to be a check of comparing whether the logical address is less than the value of the limit register. So what is this limit register? Limit register is nothing but the size of the program. So in this case, 151 is the number of instructions within the program. So that is why 0 to 150 is the logical address space and the limit register value is 151. So totally there are 151 instructions. That is why the limit register value, which is nothing but the size of the program in terms of the number of instructions. Now let us see address protection software or address protection hardware. So here what is the need of protecting the addresses or protecting the main memory? So if you look at the operating system behavior, it will not allow one process to access the memory that is occupied by another process. And also no user process should be allowed to access the operating system that is residing in the main memory. So one process should not be allowed to access the memory that is occupied by another process, and at the same time the user process should not access the operating system. So in order to make sure of that, there is address protection hardware which is implemented by using the limit register and relocation register. So CPU initially generates the logical address, consider it as 150. First of all, in order to convert that into physical address and give access to the main memory, we have to check whether the logical address that is being generated by the CPU is less than the limit register value. So here the limit register value is 151 because there are 151 instructions in the program that we have seen in the previous example. So this is the example where there are 151 instructions and the limit register value is 151. So this logical address 150 is less than 151. So only then we are going to add the relocation register value to the logical address in order to get the physical address. So in this example, we are considering the relocation register value as 2000. So that is why the physical address now has become 2150. That means this 2150 is a valid address and which can be accessed by the process within the main memory. And what if the logical address is not less than the limit register value? That means a process is now trying to access a memory region which is not part of the process memory. So that is why there is an error saying that it is an invalid address. Now let us consider an example where we have a set of processes P1, P2 and P3, and these are the limit register values 200, 500 and 100 for each of these processes. And if you look at the relocation register values, they are 1000, 1500 and 500. And this is the set of logical addresses for processes P1, P2 and P3. So in order to compute the physical addresses for the given logical addresses, first of all, we have to check whether the logical address value is less than the limit register value. If it is less, then it is a valid memory access. In such a case, we can add the values of the logical address and the relocation address, relocation register value in order to get the physical address. So check for process P1. Here the logical address is 150 and the limit register value is 200. So 150 is less than 200. So it is a valid memory access. So in order to get the physical address, we have to sum up, we have to add the relocation register value and the logical register value. So 1000 plus 150, which is 1150, is the physical address corresponding to the memory access 150 of process P1. Now, coming to the process P2, the logical address is 450. And if you compare the value of the limit register, which is 500. So 450 is less than 500. So it is also a valid memory access. That is why we can add the values of relocation register value and the logical address value in order to get the physical address value. So 1500 plus 450, which is 1950. Now coming to the process P3, here the logical address is 110, but the limit register value is 100. So logical address is beyond the limit register value. So it is a invalid memory access. So in such a case, there should be an error that has to be raised saying that it is a invalid address. So with that, we came to the end of this session. In this session, we have discussed about the memory hierarchy and the functionality of the memory management, the logical and physical addresses, and the address translation mechanism by using which we can convert the logical address that is generated by the CPU to the physical address, which is referring to the main memory. So with that, we came to the end of this session. We'll meet again in the next session. Thank you.